Welcome, welcome, welcome. Pull up a chair, metaphorically, of course, since you're presumably already sitting down. Today we're diving into what might be the most powerful, most misunderstood, and most surprisingly ancient tool in the construction manager's arsenal, the Gantt chart. Or as I like to call it, the reason your project manager keeps staring at colorful rectangles and nodding knowingly. Now I know what you're thinking. A bar chart? I learned bar charts in primary school. And you're right. That's precisely the genius of it. But don't let its simplicity fool you. This humble grid of horizontal bars has coordinated wartime production, built megadams, and managed highway networks spanning entire nations. By the end of this lecture, you'll never look at a horizontal rectangle the same way again. Let's get into it. So, what exactly is a Gantt chart? According to scholars Popescu and Cherengam, and yes, those names will absolutely be on the exam, it is, quote, a graphic representation of project activities shown in a time-scaled bar line with no links shown between activities. Let's unpack that. Graphic, time-scaled, no links. 3 words, 3 concepts. That's your entire definition. This is not the kind of tool that requires a PhD to understand. Your site foreman can read it. Your client can read it. Frankly, a mildly educated golden retriever could probably read it. And that is its superpower. Developed in 1917 by one Henry L. Gantt, this thing is now a full-blown industry standard. And its core utility? The ability to visually process timescales instantly, something that complex logic networks, for all their mathematical sophistication, simply cannot do. You can stare at a critical path network all day and still not know if you're on track. Glance at a Gantt chart for 3 seconds and you know exactly where you stand. That, my friends, is the power of a good picture. Now, every great invention has an origin story, and Henry Gantt's is something straight out of a Hollywood film. Born in 1861 in Maryland, literally at the outbreak of the American Civil War, young Henry's family lost their plantation and wealth in the conflict. So right from the start, life was teaching him a very important lesson. Chaos is expensive, and someone needs to get organized. To fund his education at the semi-military McDonough School for Orphan Boys, Gantt literally worked on a farm in exchange for tuition. He didn't have the luxury of skipping classes or showing up unprepared. This kid was paying for every single lecture in manual labor. Let that sink in for a moment. But hardship builds character. Gantt graduated, and then kept going, earning a degree from Johns Hopkins at just 19 years old and later from the Stevens Institute of Technology. The adversity didn't break him, it forged him, much like steel, which, as we'll see in the next slide, is exactly where he ended up working. Fast forward to 1884. Young Henry Gantt takes his first real job as a draftsman at a place called Poole and Hunt, an iron foundry that built steam engines and structural elements for the U.S. Capitol itself. Imagine that. His very first gig involved making parts for the seat of American government. Not bad for a kid who used to wake up at dawn to muck out stables. Then, in 1887, something pivotal happens. He joins a fellow by the name of Frederick W. Taylor at Midvale Steel. Now, if you've heard of Taylorism or scientific management, you know where this is going. Together, Gantt and Taylor began applying rigorous engineering principles to human labor. They wanted to understand work the same way engineers understand machines, systematically, measurably, predictably. Think of it this way. They didn't want workers just doing their best. They wanted to know, how long does this actually take? What are the inputs and outputs? Can we make it faster, better, more efficient? Efficient. It was the birth of modern management thinking, and Gantt was right in the thick of it. Now here is where things get truly dramatic. The year is 1917. The United States enters World War I. And suddenly, overnight, the demand for military equipment doesn't just increase, it explodes. We're talking about production orders jumping from hundreds to millions, hundreds to millions. The U.S. Army's Chief of Ordnance, General William Crozier, is staring at an impossible logistics problem. His arsenals are completely overwhelmed. The existing methods of tracking production, essentially lists and tables, cannot handle this scale. Picture trying to manage a city using a sticky note. That's roughly where they were. So General Crozier did what any sensible general in a crisis does. He called in an expert, and that expert was Henry Gantt. The challenge? Create a system that could visually communicate the production status of millions of items across multiple facilities in a way that any general, any manager, any administrator could immediately understand. No complex mathematics, no lengthy reports, just clarity, just insight, just action. Let's see what Gantt came up with. Before Gantt could solve the problem, he first had to diagnose what wasn't working. And the culprit? The humble typewritten table. Now, tables aren't inherently evil. They have their place. Spreadsheets, financial reports, your aunt's recipe collection. But for tracking dynamic, time-sensitive production at massive scale, utterly useless. The problem, as Gantt identified it, was twofold. First, lists cannot convey the significance of quantities. If I tell you Arsenal A produced 4,182 units and Arsenal B produced 9,961 units, what does that mean? Is that good? Is that terrible? Are we on track? There's no visual weight to those numbers. They just sit there, cold and inert. Second, and this is the killer, lists are static records of the past. They tell you what happened. They do not tell you what should have happened by now, what the gap is between plan and reality, or what needs to happen next. They offer zero insight into the future. They are, in Gantt's view, forensic documents. Great for a post-mortem. Useless for steering a ship. What was needed was something dynamic. Something that compared reality to expectation in real time. Something that screamed, "Take action here." And that's exactly what he built. And here it is, the original Gantt Chart concept applied to wartime munitions production. Look at what you see on this slide. 3 activities: munitions A, munitions B, and assembly. Each one has 2 bars, a lighter outline bar showing the plan, and a solid filled bar showing the reality, and a dashed vertical line showing where today is. At a single glance, I'm talking 1 second, maybe 2, you can see 3 things simultaneously. What was supposed to be done, what actually got done, and by how much you're ahead or behind. No report required, no explanation needed. The gap is the story. And here's what made Gantt's approach revolutionary. It wasn't just retrospective. The chart, in his own words, continuously compares the rate of work with the advance of time. It forces you to ask, given where I am today, will I make my target? And if the answer is no, it tells you exactly where to intervene. Munitions A is behind. Get more workers on munitions A. Munitions B is ahead. Brilliant. Assembly is fine. Leave it alone. That's management. That's control. That's what a Gantt chart does. Did it work? Oh, it worked. It worked spectacularly. By 1918, Gantt's charts had been deployed across Frankfurt Arsenal, naval aircraft production, and the Emergency Fleet and Shipping Board. General Crozier used the chart to do something elegantly simple but profoundly powerful. He used it to fix responsibility for action, not to record what happened, not to explain why things went wrong after the fact, but to look someone in the eye, Point to a bar on a chart and say, "You, this task, this date. What is your plan?" Accountability visualized. The shipyards shown here, producing cargo vessels at industrial scale, were coordinated with this tool. Men and materials were moved, production was accelerated, and the chart became, as one historian put it, a critical weapon in the production war. Not a rifle, not a cannon, a chart. Sometimes the most powerful weapons are the ones that bring order to chaos. After the war, the Gantt chart didn't retire. It went global. By the 1920s, it had been accepted as what contemporaries called a radical concept of worldwide importance. People were using it everywhere, in manufacturing, logistics, infrastructure. But its most iconic moments were in construction. In 1931, the Gantt chart was used to manage one of the most audacious engineering projects in human history, the Hoover Dam. Now, I want you to appreciate the scale of that. We're talking about hundreds of workers performing thousands of interdependent tasks in the Nevada desert, coordinating concrete pours, diversion tunnels, transmission lines, all managed with bars on a chart. No Primavera P6, no Microsoft project, just careful planning on paper. And then in 1956, when the U.S. launched its massive interstate highway network, tens of thousands of miles of roads connecting an entire nation, the Gantt chart was again the backbone of coordination. From munitions to monuments, from arsenals to arteries. This simple idea had grown up and was reshaping the world. Pretty impressive for a tool you can draft with a pencil and a ruler. Henry Gantt himself died in 1919, just as his methods were exploding onto the world stage. He never saw the Hoover Dam. He never saw the interstate highway system. He never saw his chart become the universal language of project scheduling across every industry on the planet. There's something genuinely poignant about that, but the world remembered him. There's a bronze Gantt chart, an actual Gantt chart, cast in bronze, permanently installed on the Mike O'Callahan Pat Tillman Memorial Bridge at the Hoover Dam bypass. Think about that. Not a portrait, not a plaque with his face, a chart. His actual invention, immortalized in metal, on a bridge overlooking the very dam his tool helped build. That's a tribute worthy of a management legend. And since 1929, the Gantt Medal has been awarded annually to honor distinguished achievement in the fields of management and service to the community. The man's gone, but his chart, his method, and his philosophy of making the invisible visible, of turning time into something you can see and act on, that lives on in every project schedule drawn up today, including the ones you'll be drawing very soon. Right. History lesson over. Now, we build things. And the first thing to understand when constructing any Gantt chart is, what are you actually scheduling? The answer is activities. Activities are the atomic units, the fundamental building blocks of your schedule. But here's where people go wrong. An activity must be the right size. Look at the example here. A concrete superstructure project. At the top level, you have the whole project. Too big to schedule meaningfully. Drill down and you get foundation, columns, and deck. Better, but still a bit vague. Drill down further, specifically into columns, and you get erect formwork, place rebar, and pour concrete. Now we're talking. This is called decomposition, breaking the project into homogeneous, measurable components. And the golden rule here is what I call the granularity rule. An activity must be measurable and controllable. If it's as big as the project, too broad. If it's as small as tighten a bolt, too detailed. You're looking for that sweet spot where you can say, with a straight face, this task starts on Monday, takes 3 days, requires 4 workers, and I'll know when it's done. That's an activity. That's schedulable. That's what goes on your chart. Now we get to actually read the chart. And I promise, this is simpler than assembling flat-pack furniture. Look at the example here. A concrete slab construction sequence. Prepare site, vapor barrier, form edges, welded wire fabric, pour concrete, finish top, strip forms. 7 activities, 1 chart. All the information you need. The horizontal axis is your timeline, in this case, hours. The vertical axis lists your activities. And the bars? Each bar tells you 2 things simultaneously. When the activity starts, the left edge of the bar, and when it finishes, the right edge. The length of the bar is visually proportional to the duration. A longer bar means a longer task. No numbers required. Your eye does the maths. Notice also the sequencing logic here. Each activity starts after the previous one, creating a staircase pattern. Site preparation comes first, vapor barrier second, and so on. This sequential flow makes intuitive sense because you physically cannot pour concrete before you've laid the wire fabric. The chart shows this naturally, even though it doesn't explicitly state the dependency. This, incidentally, is both the chart's greatest strength and, as we'll see later, one of its limitations. But we'll get to that. Here's something that trips up a lot of students. Not all of a bar's duration is actual work. Sometimes you have waiting built into an activity, and that distinction matters enormously for resource planning. Take our classic example, placing concrete and then curing it. If you draw one continuous bar from pour to strip, it looks like you need workers on site the entire time. But the reality? You pour the concrete in a few hours, then nobody touches it for 24, 48, sometimes 72 hours while it chemically hardens. The workers can go home. The equipment can be used elsewhere. The time passes, but no labor is consumed. This is where the necked bar comes in. Instead of one big continuous bar, you draw the work portion as a full bar, then a thin dotted line, the neck, representing the waiting period, and then another full bar for the resumption of work when you strip the forms. It's a subtle graphic distinction, but it carries enormous practical information. Permits work the same way, inspections too. You submit, you wait, you're cleared, you continue. The waiting period is real calendar time that affects your schedule, but it doesn't consume your resources. Represent it honestly. Your budget will thank you. So far, we've been treating the Gantt chart purely as a time tool. But here's where it gets genuinely sophisticated. The y-axis can carry quantitative data too. This technique is called resource loading, and it transforms your Gantt chart from a mere schedule into a management dashboard. Look at the example here, a multi-floor building project. The bars show the schedule for each floor level from foundation through to the site clearance. But overlaid on top, an S-curve tracking cumulative man-hours. The right-hand y-axis tells you, at any point in time, how many total man-hours have been consumed. By the time you reach the end of the project, you've spent approximately 6,800 man-hours. But you knew that from week 1 because it was loaded into the chart at planning stage. You can do the same thing with costs, with quantities of materials, with equipment hours. The chart becomes a financial forecast and a resource planner simultaneously. This is why senior managers love Gantt charts. They can see the time and the money in one picture. And this is also why, fair warning, overloaded Gantt charts become impenetrable nightmares. More on that shortly. But for now, appreciate the power of loading your chart thoughtfully. And now we have arrived at one of the most beautiful tools in all of construction management, the S-curve. And it is beautiful, not just aesthetically, but mathematically and practically. Once you understand it, you'll see it everywhere. Why does the cumulative expenditure curve on a construction project look like an S? Because all construction projects, all of them, follow the same basic rhythm. They start slow, mobilization, permits, setting up site, initial planning. Then they hit full stride and everything accelerates. Peak construction activity, maximum crews on site, maximum spend. Then they slow down again toward the end. Finishing works, snagging, commissioning, closeout. Slow, fast, slow. S. This isn't a coincidence. It's a fundamental pattern of how complex work unfolds in the physical world. And once you've loaded your Gantt chart with resource data, this curve emerges automatically, which means you now have a planned S-curve. And during execution, you plot an actual S-curve. And the gap between those two curves tells you at any moment whether you're ahead of schedule, behind schedule, over budget, or under budget. We'll explore that in much more depth when we get to earned value management. But remember, the S-curve begins here in the Gantt chart. Now we're getting into the real world. And in the real world, plans don't survive contact with reality. Rain happens. Materials arrive late. Subcontractors disappear without explanation. Clients change their minds on a Tuesday afternoon. This is construction, not a computer simulation. So how do you track what actually happened versus what you planned to happen? You use the as-planned versus as-built comparison. Look at the roof replacement example here. The outlined bars are the as-planned schedule, your original prediction. The solid filled bars are the as-built record, what actually happened. And that vertical orange line is the data date, today, the point at which you're taking stock. What does this tell us? Remove old roof, completed slightly ahead of schedule. Replace rotten rafters, completed, 100% done. Install sheathing, currently in progress, slightly delayed. Install shingles, hasn't started yet, only 30% of the planned duration remains before the original deadline. Houston, we have a problem. This is the chart earning its keep. Not just as a planning tool, but as a forensic document, a record of what happened, and a management trigger that tells you when to act. The earlier you detect the gap, the cheaper it is to close. Here's a practical problem. What happens when your project has not 7 activities, not 70, but 700 or 7,000? You cannot show all of them on one chart without the whole thing becoming a wall of tiny bars that nobody can read from more than 30 centimeters away. Enter the summary bar. The concept is wonderfully elegant. You group related activities, say all the tasks within the framing phase, and collapse them into a single summary bar that spans from the start of the first activity to the end of the last. That single bar says, framing runs from week 8 to week 14. That's all upper management needs to know. Then, separately, in your detailed schedule, which you use to actually run the site, you expand that summary bar into all its component activities. Install bottom plates, install studs, install joists, and so on. 2 levels of communication. 1 chart for the boardroom, 1 chart for the site foreman. Same data, different granularity. This technique lets you scale from a small project to a mega project while keeping your communications appropriate for your audience. The golden rule? Match the level of detail to the decisions being made by whoever is reading it. The CEO does not need to know when you're installing each individual joist. The framing crew does not need to know the project's overall financial forecast. Give people what they need to do their jobs. We've covered a lot of sophisticated applications, so let's come back to first principles. Why, after more than a century, does the Gantt chart still dominate? 3 reasons, 3 words: universal, accessible, proportional. First, universal language. A Gantt chart can be read by a structural engineer, a client with zero technical background, a bank funding the project, or a government regulator reviewing your program. No special training required. No decoding. Bar long, task long. Bar early, task early. It is the Esperanto of project management, except unlike Esperanto, people actually use it. Second, accessible creation. You can draft a basic Gantt chart with a pencil, a ruler, and some squared paper. No software license required, no training course. This was true in 1917, and it remains true today. In remote locations, in early-stage planning sessions, in the back of a taxi on the way to a client meeting, the Gantt chart is always available. Third, proportionality. Bar length equals duration. Your brain processes this instantly, without conscious thought. A bar that's twice as long represents twice the time. That visual intuition is built into your neurology. Complex logic networks don't give you this. Tables don't give you this. The Gantt chart gives you this for free. But, and this is a crucial but, one scholar warned that the user must be careful not to overload them and eliminate their main advantage, simplicity. Remember that every time you're tempted to add just one more layer of data to your chart. All right, time for some honesty. For all its magnificence, the Gantt chart has an Achilles heel, a fatal flaw, a weakness so significant that entire alternative methods, specifically the critical path method, were developed precisely to address it. That weakness is, the Gantt chart cannot show why. Look at the 2 tasks here, Task A and Task B. Task B starts in week 4. Why does it start in week 4? Is it because Task A must finish first, a logical dependency? Is it because the equipment needed for Task B only becomes available in week 4, a resource constraint? Or is it because someone made an educated guess when they drew the bar, a subjective estimate that might have absolutely no logical basis? The chart cannot tell you. It shows what happens and when. It is silent on why. This matters enormously in practice. Imagine Task A finishes 2 weeks early. Should Task B now start 2 weeks earlier? If it's a logic dependency, absolutely yes. Move the bar, save 2 weeks. If it's a resource constraint, maybe. But you need to check availability. If it was an arbitrary guess, well, now you have to go and actually think about it. The chart gives you no guidance whatsoever. This is why, for any project of real complexity, the Gantt chart is used in conjunction with logical network methods. It presents the result, the network explains the reasoning behind it. So here's how the Gantt chart fits into the modern scheduling world, and this is an important conceptual shift. For most of its history, the Gantt chart was both the planning tool and the output. You drew bars. The bars were your plan. End of story. In the digital era, something fundamental changed. Software like Primavera P6 and Microsoft Project work like this. First, you input your CPM logic, your activities, their durations, their dependencies. The software processes all of that, runs the critical path calculations, determines the mathematically optimal sequence, and then generates the Gantt chart as its report. The Gantt chart is now the output of a more rigorous analytical process, not the input to it. Think of it like a GPS. You enter your destination and your constraints. Avoid motorways. I have a meeting at 9 a.m. I'm driving, not walking. The GPS runs the algorithm. And what does it show you? A map. A visual route. The map didn't calculate the route. The algorithm did. The map just makes the route comprehensible. That's what the Gantt chart does now. It makes the CPM calculation comprehensible to every human being who needs to understand it. It is the face of modern scheduling software, and it remains, a century after its invention, the most effective face anyone has designed. And so we come to our final slide and your practical takeaway for the day. The scheduler's checklist. 5 questions that determine whether your Gantt chart is actually worth the paper or the pixels it's drawn on. 1. Breakdown. Are your activities homogeneous and measurable? Can you put a number on each one? If not, break them down further. 2. Estimate. Do your bar lengths reflect realistic durations? Not optimistic durations, not wishful thinking. Realistic durations based on evidence, experience, and productivity rates. 3. Load. Have resources been assigned? Man-hours, budget, equipment? A schedule without resources is a wish list. It only becomes a plan when it's resourced. 4. Refine. Are necked bars used for non-continuous work? Have you honestly represented waiting periods, curing times, permit periods, inspections, rather than hiding them inside continuous bars? 5. Review. Have you identified and verified the hidden logic dependencies? Do you know why each bar starts when it starts? Are those reasons defensible? If you can answer yes to all 5, congratulations. You have a schedule. Not a chart, but a genuine management tool. One that Gantt himself, who worked a farm to pay for his education, who solved the logistics crisis of the First World War, and who is immortalized in bronze on a bridge in Nevada, would be rather proud of. Now go build something magnificent.